Hello and welcome to section 9.7. This is the last day or last section in our chapter here. The answers for 9.6 day 2. I tried to keep the assignment a little bit lighter for you guys since previous day was quite a bit of problems with factoring. So what we're going to be working on today is special products. Again, factoring. Only this time it's going to be easier. All of them are going to be nice and neat, and there's going to be patterns. I think you guys will like this. We worked with x plus 4 times x minus 4, and what happened when we multiplied them together, the 4x and the negative 4x gave you 0, and you end up with x squared minus 16. So that's what we're going to start with, except for we're going to go backwards. We're going to go from that to that. Okay. Now, what's going to trigger this is square roots. If you can square root the first number, which you can, this is y, and you can square root the second number, this one's 2, it's going to be really, really, really easy. And there's a subtraction symbol between the two. So I'm going to show you guys what to do when you notice that they're perfect squares. If you notice that those two numbers are perfect squares, use them. Do y and minus 2 and plus 2. And the reason why that works out is because the 2y and the negative 2y reduce to 0, and you end up with y squared minus 4. So y minus 2, y plus 2. And that's it. This one, if we square root this, we get 5m. If I square root this, I get 6. So those are going to be the numbers we're going to use for our box. 5m minus 6, 5m plus 6. That's 25m squared. That's negative 30m. That's positive 30m. And that's negative 36. That gives us what we want. So we have 5m minus 6. And then 5m plus 6. And you can do these over and over and over again. Like this one here is x, and this one here is 7y. I basically don't even need to do the problem. I know that that's going to be my answer. So you get kind of good at this, and you recognize the pattern. Like this one's going to be 2x minus 3 and 2x plus 3. So that's kind of why these are nice. They are very, very quick problems once you see the pattern. Some of the problems in your homework, they are not going to be perfect squares, but you can actually manipulate them so they are. Anytime you can factor out GCF out of any polynomial, you always do that. So we're going to first put this into the proper form, switch around the order, and then we're going to factor out the GCF, which is negative 2 here. Okay, so I don't even like how this is. I wouldn't even do that. I would do what I did here. So you get negative 2, and then you end up with 9n squared minus 4. And then from here, square root of that is 3n, square root of that is 2. So it's negative 2, and then 3n minus 2, and then 3n plus 2. And there you go. So sometimes it doesn't start off looking like it's going to be a perfect square problem, but you can turn it into. But in general, though, always factor first. If you can factor out a GCF out of it, always do that. So like I said, I don't like this answer here. I do not like that answer. I like mine better. Okay, and then we had things that look like x plus 4 times x plus 4. This was called a square of a binomial. We took a binomial and we squared it, and you got x squared and 4x and 4x and 16, and that gave you this guy right here. Okay, what we're going to do is we're going to go from this to this now, and it's called a perfect square trinomial. So you're going to be given what we call a perfect square trinomial, and we're going to convert it to the square of a binomial. So again, square root x3. This is going to be x plus 3 times x plus 3. And again, you can use the box if you want to check. X squared, 3x, 3x, and 9. There's your x squared plus 6x plus 9. Boom. And so this can be written as x plus 3 squared. Either or is fine with me. Square root this, you get h. Square root this, you get 2. h plus 2 times h plus 2. Now these have equal signs. I just noticed that. So I should put an equal sign here. So x equals negative 3. And this one, h equals negative 2. Okay. How about with subtraction? Okay, square root this, we get x, we get 5. Only thing difference here is I'm going to use x minus 5 and x minus 5 because I need it to be negative 10x. So this would be x minus 5 squared. So x equals 5 if I solve that equation there. And the same thing for the last one. This is going to be n minus 6 times n minus 6. So n equals 6. And there you go. So hopefully a little bit easier than what we've been working with. That's it. Thanks for tuning into 9.7.